Hello and welcome back to Verbose Mode by TaxCare at Dev2 Next, a 2025 from sunny Colorado Springs in Colorado.
Indeed.
My next guest is Tis. Welcome, Tis.
Nice to be here.
And you mentioned that you have two talks on a very, I would say, broad topics. One of them is Spring Framework that we all know and love, and especially in the Java community, and functional programming, which is absolutely something very, very far away from a Java as a programming language, where Spring Leaf. Oh, interesting. Okay, so that would be my first question. How do you marry the two? What has functional programming has to do with Spring?
Well, in one thing, I sort of hate the term functional programming. I'm very big more on fundamentals of software engineering. So what are the underlying problems that we're trying to solve here? I sort of call it functional programming because it has very good ways to describe those problems. So I tend to try to avoid functional versus object-oriented programming because they're both trying to solve the same underlying problems. And so it's more about concepts and what are we trying to solve, and you can do that in any paradigm and in any language. You can do it in Java, you can do it in JavaScript, in Python. You all face the same underlying problems, which is, in my talk, it's about compositional problem solving, state and error management, and side effect management. And no matter what language or framework you use, you need to solve those problems.
Yes, that's true, but you solve them very differently.
In a way, there's what are we trying to do, and then there are the mechanisms that the language allows you to solve those things. So, for example, if you think about error management, in my talk, I will, for example, say there are two different kinds of errors. There are recoverable errors and there are unrecoverable errors. And for unrecoverable errors, there are runtime exceptions that are amazing for those. And for recoverable errors, there are other options. And Java, for example, has checks exceptions, it has optionals, it has the new shield classes, creating shield types. And like languages like a Haskell or Scala and such, they also have iders and such to deal with the same thing. If you use Kotlin and use the error library, you, for example, have the whole race API. But these all try to solve the same problems of recoverable errors. So my opinion is, if you start thinking in those terms, then you probably find a good solution within your language. Or find any way of dealing with that. For me, it's most importantly that you consciously think about those solutions instead of purely relying on the language, because you don't need all the language features in order to do
it makes sense. It's almost like you're talking about like a higher level of abstraction.
Yeah, that this is a problem we're solving, and then find the best way to solve it in your language.
And this kind of a next level of abstraction brings us to Spring, because this is what this framework is about, right? How can we introduce this level of abstraction that will help us focusing on problems and not on particular ways to solve them?
And in this case, it's a broad topic, but I'm trying to, I do a lot of knowledge sharing. That's how I got into functional programming, because I basically have been coaching juniors for about 10 years. And the really nice thing about juniors is that they keep asking the question, why? So why do you do that? And it turns out if you ask the question why enough, you end up with the underlying problems. And I never studied functional programming. I just learned about it. If you just ask the question why enough, you automatically start learning functional programming.
Interesting. Give me an example.
So if you ask the question why do you use singletons?
Yep.
So for me, that was at some point a very difficult question to answer, because I knew what a singleton was. You only have one instance. Why do you need one instance? What's the benefit? Well, there's a performance reason as a benefit, but you might also think, hey, that's a sort of state-related problem. Why do you want only one instance? Well, you only want one if that particular state is important. Otherwise, you don't want that state being divided upon multiple instances, because that could cause problems. But if you only have one instance, that problem is solved. So there's a performance thing, but there's also a state-related thing. Hey, and that whole state discussion, now we're going into functional programming theory.
Okay,
territory.
okay. So how do what is the next why? So the next why is okay. I want I want a single state of something throughout the entire application.
For example, yeah.
Yeah. So what is the next step to get to functional programming?
Well, it's mostly a lot of these functional programming things are based on certain ideas. And in my talk, for example, with state, I go into state management, like what are issues and what are, like there are a lot of issues with mutable state. Why those issues exist and how do you solve them? In my case, in a non-dogmatic way, because mutable state is actually very useful in a lot of cases, but how can we use mutable state while avoiding the issues with mutable state? And basically just people ask me questions on, so why do you need to do that? Why do you need that? Forced me to think about these things. And basically stuff I talk about is like 10 years of being forced to think about these questions as why do you need to do that? At some point I even made the talk Monads Explained. Even though I don't have a background in this, I thought I'm pretty good at explaining complex issues in an easy way, and monads are infamously impossible to explain.
Absolutely.
So I wanted to give myself a challenge by explaining monads with just Java.
Okay, this is interesting.
And then luckily I have some friends who actually know this stuff.
Okay,
So they can help me with like those small details.
And verify that what you're saying is actually correct.
So I actually verified it with people who really know this stuff. But that's also again for figure out, so why do we want to do these things? What problems do they solve? And that's also what I'm talking about with Spring. Like what are the underlying principles of Spring? Because again, I was just guiding an intern and he wrote a bit of Spring code. And at some point he came to me and said, oh, why do I get a null pointer here? And then I realized, I had exactly the same issue 12 years ago where I didn't understand that. So apparently there's still a big need of people coming into Spring who don't know the underlying principles on what Spring was built. And in this case, I talk about dependency injection, the application context, and aspect-oriented programming. So what's the ways of thinking you need to understand those things? So next time you have any problem in Spring, you can just realize, oh, that's probably a proxy, and that's how Spring uses it underneath. So this might be the angle how I need to solve my problem. So it's all about what are the underlying thought patterns and how can you use those to attack the more specific problems.
Interesting.
So that binds the two topics. Like it's a broad thing, but both are in the end underlying concepts, ways of thinking you need to understand the bigger picture.
Yeah, the question that we started. Tis, that was very, very interesting. Thank you very much for coming. And you all folks, stay tuned for more episodes of the Verbose Mode by TaxCare at Dev2Next. We have tons of more fascinating content coming to you very, very soon.